So shall we start? I think we have sufficient number and we can start, right? So if you have any doubt, any question, you can ask me in the meantime, and if no, then we'll go ahead. Okay, someone may please let me know.
Okay, so we can start.
Okay, thank you. So, in the previous classes, all those things regarding what is the use of gears, okay, so comparison of gear drive with the other type of drives, okay, its capabilities, some of the limitation, okay, all those things already we have discussed. Later on, all those classification, etc., based on the velocity of drive as well as based on the uh, like the relative position of the shaft axis, those things also we have discussed. There we have discussed basically the spar gear, okay, the internal meshing, external meshing, rack and pinion, what is their capabilities, helical gears, double helical gears, okay, all those helix angle or right-handed gear or left-handed, all those teach, those things we have discussed. Okay, similarly herringbone gear, its capability, and I told you to find out some compare double helical as well as herringbone gear. And later on we have discussed about all those bevel gears, its use in differential, and how does a differential work, those things also we have discussed. And it can be straight bevel, it can be spiral bevel depending on the type of teeth that we have cut on the bevel gear, okay. So those things also we have discussed. Later on we have discussed about worm gear and worm and worm wheel. There we have seen its capability, like one of the thing is very high velocity ratio, okay, so that conversion is very, it's possible. Similarly, you have seen its self-locking kind of characteristics, whereby we can by moving the worm, okay, we can rotate the, by rotating the worm we can rotate the wheel, but vice versa is not possible. But in the case of rack and pinion, if you recall, so this case, okay, here both the motions were possible. That means if you can provide rotational motion to the pinion, you can expect some motion in the translation motion in the rack. And by the rack also, if you can provide some translation motion to the rack, okay, it can rotate the engaged, or you can say the meshed pinion which is in mesh with it, okay, it can rotate that. So both the thing, both the way motion conversion was possible here. But in the case of our rack and this worm and worm wheel, it was not possible. Okay, we can very easily by rotating the worm we can easily rotate the gear. But if you try to rotate the gear, and if you expect that I'll be able to rotate the worm, okay, then it will be very difficult. Okay, generally it's not possible. Okay, so later on we have discussed some, have started discussing about the initial nomenclature, and today we'll be going to the different gear terminologies. We'll discuss with respect to spur gear. So up to this much, if you have any doubt, you can right now you can ask, and if you have understood, you can just let me know, and I will move ahead with this particular gear terminology. Okay, I hope the things are clear up to this much. So today we are going to discuss about the various gear terminologies, and for that we have taken this spar gear teach as a reference. And now, if someone asks you to show the different terminologies with respect to a particular figure, then it's advisable to consider, if nothing has been mentioned, then you consider your spar gear only. Okay, and in that particular case, to show all the different terminologies, we have to draw, we'll be drawing kind of 3D kind of view, okay. And in that case, to show all the different terminologies, at least two number of teeth we have to draw. Only if you draw only this particular single teeth, then you will not be able to show some of the other terminologies which are associated with it, okay. Now before coming to this particular figure, the left hand side, prior to that, once again we'll be just discussing the right hand side figure, where two different views we have shown for the two meshing gears, okay. So now, from our previous discussion also, we already know if this is a gear, and we are with this particular circle, we are denoting two gears which are in mesh, okay. And this is the point, that is the pitch point, at basically which, that is the point, this pitch point where basically the teeth from both the meshing gears, suppose gear A and gear B, they meet here. Okay, so the contact is there at the pitch point if we consider in terms of point. And if you that whole line contact, we know that if we consider the thickness, so from this particular figure it will be evident. So this is another view of it, top view. Okay, so this is from here to here, this is this particular gear, the bigger one, and here you can see a line that we are showing. Actually this is the mesh. Here actually they are, that means they are meshing. Okay, and if you consider the whole thickness, basically it's a kind of line. So pitch point is the point with respect to which we draw all those circle, etc. Like pitch circle that we draw, we'll discuss it about it. So this circular way, whatever we show the gears without showing the teeth and all, so basically those circles we actually draw the pitch circles for both the meshing gears. And now if you consider this particular view, then these two gear we can consider like pitch cylinders. Basically they are nothing but the gears actually. And this particular line actually it corresponds to this particular position where they are in mass. Okay, you can project it and you can get this particular line. So this is the line. Okay, pitch line. Okay, so and definitely these are the shaft position only, and whatever the diameter of this particular pitch circle, that is definitely pitch diameter or pitch circle diameter, and it gives you the indication about the size of the gear. Okay, if the pitch circle of a particular gear is kind of the radius or the diameter is more, the size of the gear is that means more. Okay, it gives you the direct indication about the size of the gear. Okay, so now what are the different the gear terminologies that we are going to discuss? So for that, as you can see from this particular figure, so basically this kind of one drawing you are going to draw. So actually it's a part of this particular circle, that means on which we have got suppose the teeth. Okay, so the whole circle we may not draw, but actually suppose, sorry, so this particular teeth, suppose one teeth. Okay, which is here on this particular, suppose here. Okay, and suppose here under teeth we have. Okay, so this particular two teeth, minimum two number of teeth we have to draw, and these teeth we can avoid, the other teeth we can avoid, or if you want to show, that is up to you, but actually that is not going to give you any more gear terminologies. So we'll be mostly interested in drawing these two or one pair of consecutive gear teeth. And for showing all the different terminologies, actually we'll be considering its thickness. Okay, and considering its thickness, the whole gear actually we are going to, the gear teeth we are going to show. Okay, so this way you can draw two gear teeth, and with respect to that you can, so right now don't mind my drawing, so actually it's not good. So this way we are going to draw this particular, this pair of teeth. Okay, so now what are the different terminologies those are associated and how we can define them. So in the subsequent slides, basically we have got the different nomenclature, their definitions, and with respect to that figure, I'll just come to this particular slides. Okay, I'll just go through the definition and we'll show it with respect to this particular figure. Okay, so now first thing we are going to discuss about the pitch surface. So now actually the pitch surface is like just like we have discussed about the pitch circle. Okay, the imaginary thing. So pitch surface is the surface of the imaginary rolling cylinder, or maybe a cone depending on the type of gear, that the toothed gear may be considered to replace. That means just like the actual gear we have replaced with these particular circles, drawing the pitch circle. Okay, similar is the pitch surface. Another word terminologies we can have the pitch surface. So it is nothing but the surface of the imaginary rolling cylinder that the toothed gear may be considered to replace. Just like this gear. So these circles you are not going to directly see on this particular gear. The gear will actually look like this. Okay, this is the actual representation of this particular gear, but we are representing with this particular circle, which are actually imaginary circles, but they are from the consideration of this gear, actually they are very important. So similarly we can have pitch surface. Next, pitch circle, just like already we have discussed, it's the imaginary circle which by its pure rolling action it produces the same effect as that of the actual gears under reference, which are properly meshed. Okay, we have already discussed this. Okay, this is the pitch circle, these two drawing are pitch circle, and here in this particular figure actually the contact remains somewhere here. Suppose this particular teeth, and if I draw, suppose this is a particular gear, suppose gear A, and if we have another gear, okay, definitely the which is going to match with it. Okay, so that gear, don't mind my drawing. Okay, it's difficult to draw in the laptop. So in that particular case, the other gear maybe it may be somewhere here. Okay, and the teeth from this particular other gear, it is coming in. It will be somewhere here. Okay, it will fill up this particular portion. Okay, it will be here. Okay, similarly, suppose this this way, next this. Okay, next maybe this way or like that. Okay, so basically if you consider this teeth, suppose from gear B, okay, this is gear A, this is gear B, which is in mesh with it. So this is the teeth for it. Okay, so these are the tooth considering. And so actually here somewhere here along this particular line, I am not drawing the 3D kind of thing. So actually here they have got the contact. So for this uh, gear, actually through this particular point where basically it is having the contact, so this becomes the, for it becomes the pitch circle. Similar for this particular gear also. Okay, so this becomes the pitch circle. Okay, so pitch circle is, that means somewhere here it passes through like this. So in this particular figure, so here we have got this particular pitch circle, this one, this circle which is passing through the pitch point, which is in contact actually. Okay, this is the pitch circle. Okay, next we have the pitch point. So pitch point is nothing but the point of contact of the two pitch circles of the mating gears. So wherever this particular two pitch circle from both the mating gears or the meshing gears meets, actually that is that particular point is nothing but the pitch point, this particular point. Okay, in this particular figure. So here in this particular case, so if I draw both the circle which are passing through both the pitch circles from both the meshing gears, so wherever they meet, that will be the pitch point. Okay, next we have got addendum circle, or as well as the root circle or the addendum circle. So now what is addendum, what is dedendum, we have to know prior to discussing about addendum circle or dedendum circle. So this addendum, this word, it is nothing but the radial distance between the pitch circle and the addendum circle. So now the addendum circle is the circle, okay, a circle which is bounding the ends of the teeth, okay, in this particular way. So now this upper portion, okay, so whenever if we consider actually a circle which is passing through the, it is bounding the upper portion of this particular teeth. Okay, so this bigger circle is nothing but the addendum circle which is passing through the addendum. Okay, so this is known as the addendum circle. Similarly, we have root circle or the addendum circle. So it is the circle bounding the spaces between the teeth. So it is the lower one. Okay, lower one is passing through the addendum. So you will see another circle we can draw, imaginary circle. These circles are all imaginary circles, but for discussion, for knowing about the different terminologies, or later on for analysis as well as problem solving purpose, this will be important. So this way we will have the addendum circle here. If you can look here, okay, so the, which is the face portion, okay, the root portion actually it is encompassing. So that particular circle is, imaginary circle is addendum circle. And we have the words addendum and addendum. So it is the addendum is the radial distance between the pitch circle and the addendum circle. So where is our pitch circle? Pitch circle is passing somewhere from here. Okay, in the mid we have the pitch circle. Actually the imaginary circles from both the meshing gears. Okay, we have the pitch circle here. So addendum is this radial distance. Okay, radial distance means what? Along the radius. So you should not draw like vertical or like this. Okay, actually if I produce this line, they will meet at the center of this particular circle. That means, okay, so this is radial distance. So radial distance from the pitch circle to the addendum circle, this particular length is, radial length is addendum. Similarly, we have the word dedendum, which is the radial distance from this particular pitch circle to the dedendum circle. Okay, so this radial distance is dedendum. So you should not draw like vertical, or you should not draw so in this particular direction. Okay, that means this much is addendum, this much is dedendum. So try to draw it in a fashion which will look like as if we produce this particular line, it is going to meet at the center of this particular circle. That means if this is suppose if from this particular figure, so if this is the center of this particular circle, if I draw like this, so these are the radial distances, right? So this is the case. So if I show with respect to this particular figure, okay, suppose this is don't mind, this is I am showing like a straight line, but it is I am trying to show the circular portion of this particular suppose circle, okay, it's circular random circle. Don't mind my drawing because I am drawing only a small portion, so I can approximate with the straight line. Okay, I can approximate a curve with a straight line for very small portion. So consider as if these are the portion from this. This is the suppose addendum circle. It is turning like this. Suppose after this, so it is going like this. Okay, encompassing the particular circle. Okay, and suppose this is the pitch circle. Okay, so this is the addendum circle. This is suppose if I complete the circle, this is the pitch circle, and suppose black is the root circle. Okay, the addendum circle. Now in that particular case, radial distance. That means this particular distance. This much is addendum. This much is the addendum. And I am saying telling you not true. So like this. Suppose you have drawn the diagram and you are showing. Suppose this is the addendum. Suppose and this much is the addendum. Try to don't do like this. Try to make it because it is from the figure. It will be very evident. If I just draw like this, okay. If I produce, they are not the radial distance. They will move like this. But if you show in this particular fashion, suppose, okay, so it somewhat looks that okay, it will if I produce, it is actually the radial distance we are talking about. Understood?
Yes, sir.
Okay, thank you. So similarly, we have another word known as clearance. So it is nothing but the difference between the addendum of one gear and the addendum of the mating gear. So what is the meaning? So basically, see, if we discuss about this particular suppose gear, okay, this is one gear we're talking about, gear teeth from suppose gear A, okay, and this is the mating teeth suppose from suppose mating teeth from gear B and so on. Okay, so now just like gear A, this is gear B. Okay, so just like gear A, the similar terminologies are there for the gear B also, right? So suppose if I draw this particular circle in case of gear A, so it is the we are talking about the addendum circle. Similarly, if we discuss with respect to gear B and if we draw this particular circle which is passing through the teeth of suppose gear B, so it becomes the addendum for this particular gear B addendum circle. This is the addendum circle for gear A, and suppose uh, the other one, the lower one, we are trying. Okay, so and this is the addendum circle for suppose gear A. Okay, this is for gear B. Addendum circle for gear A, addendum circle for gear B. So you can see that in that particular case, actually some clearance is there in between them, right? So this must. So this particular clearance, that is the difference between the addendum of one gear and the addendum of the mating gear. Actually, it gives you the clearance. So here you can see. So this particular distance is actually the clearance. Okay, that we are showing here. Similarly, we have the face of a tooth. So face is the part of the tooth which is tooth surface which is lying outside the pitch surface. So this particular portion, okay, this particular face, okay, the surface portion, if you consider the upper one, okay, this particular face is known as this is the face of this particular gear. Similarly, we have flank of a tooth or the flank of a gear tooth. So it is the portion of the tooth surface which is lying inside the pitch surface. Okay, so this is the pitch circle, and along the pitch circle, that pitch surface we have. Okay, so this dividing line, the below part, bottom part. Okay, this bottom surface is the flank surface. Upper surface is the your face surface. Okay. Next, circular thickness, which is also sometimes known as the tooth thickness. It is the thickness of the tooth which is measured on the pitch circle. So now you can see why pitch circle is important, concept of pitch circle, because most of the measurement we do along the pitch circle. So it is the thickness of the tooth which is measured on the pitch circle. Okay, and it is the length of an arc and not the length of the straight line. So if we are talking about this particular we are talking about the tooth thickness. Okay, so in that particular case, if you see from here to here, okay, for this particular tooth along the pitch circle, so whatever is this particular thickness, it is the tooth thickness for this particular tooth. Okay, and this is the arc, because we are talking about part of this particular pitch circle, so it is the arc length, not the this way straight length. Okay, so this is along the pitch circle, so this much is known as the tooth thickness of the tooth. And we have another word, tooth space or pitch depth. It is the distance at distance between the adjacent teeth along. Once again, it is measured on the pitch circle only. So now you see why drawing two adjacent teeth is important. So this teeth and this teeth, in between them along the pitch circle, if we see how much is the distance it is there or the difference it is there. So this arc distance is the width of space or the tooth width. Okay, sometimes also known as the width of space. Next, we have a very important concept known as the backlash. And prior to that, we'll be discussing the circular pitch. What is circular pitch? So this distance, okay. So suffix p suffix c, we go for circular pitch. So it is the distance of a point on one tooth to the corresponding point on the adjacent tooth. Once again, along the pitch circle. So if I consider, suppose this point from teeth A and this particular corresponding point from the second teeth. So along the pitch circle, whatever is the distance, that is the circular pitch. Similarly, I can consider, suppose from this point, from this teeth to the corresponding point here to this particular teeth, that also will be called as the circular pitch. Or any other point, suppose the midpoint here and the midpoint from the second teeth. So that must the distance along the pitch circle. Okay, all of them are actually circle or arc length or the circular length. Okay, so that is this. Similarly, we have another word known as the face width. So if you consider the whole thickness, and this way if you consider this particular length is known as the face width, or sometimes the tooth width also we consider. Okay, and the upper portion, the upper surface for this particular teeth, that is the top plane portion, and the bottom surface, this surface, okay, or here you can see this surface will be known as the bottom lane. So this is top lane, this is bottom lane. Similarly, the radius of the this like the angular, okay, not angular, sorry. So radius that is given in this particular root portion in this to this particular teeth, okay, that is nothing but the fillet radius we sometimes provide. Okay, and the total depth of working, it is, or the working depth, it is known as, it is nothing but the from addendum portion, okay, addendum plus dedendum minus this clearance, that will give you the working depth. Okay, that means within this particular depth actually the, because see, whenever we are talking of working of this gear, so we always mean that there has to be two gears which should be in proper mesh. And we know whenever we have the meshing of two gears, so basically there is some clearance that is there in between the two teeth. Okay, it should not, in normal case it should not touch this particular root portion. Yes, the suppose the teeth from the other mating gear which will occupy this space, width of space or space width. Okay, so it will fill this particular portion, right? Because teeth from the other gear, it will fill here and so on. And in that particular case, so working depth becomes addendum plus dedendum from this particular teeth minus the whatever is the clearance that we have. Okay, and right now pitch circle we have discussed. And pitch circle, how we can get the, what is the expression to get the pitch circle. So these are important, these expressions we'll be using, you have to note them down and memorize them also. So pc, it is pi d by t, where d is the pitch circle diameter we're talking about, and t is the number of teeth that is there. Okay, so up to this much, is it okay? I hope it should be okay.
Yes, sir.
Okay. Similarly, we have some another words or nomenclature like diametral pitch, p suffix d. So this diametral pitch, it gives you the indication about the, it is the number of teeth per unit length of pitch circle diameter. And important thing is, it is considered in inches, the word diametral pitch. And as all those things we are talking about, it says basically in the US this particular term is more used. Okay, diametral pitch. So it is the number of teeth divided by actually the diameter. Okay, pitch diameter. So T by D, and generally it is US customary unit. Okay, and to designate similar kind of thing, we have the most important word, that is the module of a gear. So module generally with small m, it is the symbol that we generally use for denoting module. So actually module is nothing but it's the ratio of pitch diameter in millimeter to the number of teeth that is there. Okay, so and this term module we use in SI unit in place of this diametral pitch word. So if you go in the US and on, they will be using mostly using the word diametral pitch, okay, to designate similar kind of thing. But we use the word, we'll be mostly using the word module, and it is nothing but it's the ratio of the pitch diameter in millimeter to the number of teeth. So m equal to d by t. So you have to remember this. It should be very important. Similarly, we have another word gear ratio denoted by capital G. It's the actually the ratio of number of teeth on the gear to that of the number of teeth on the pinion. Okay, so capital T, that is the number of teeth on the gear, that is the bigger wheel we generally consider as the gear, and the smaller wheel we generally consider as the pinion. So T, capital T by small t, it is going to give you the gear ratio. Okay, so next, up to this much I hope everything is clear. Correct.
Yes, sir.
Okay, thank you. Now we have said that there is a very important concept of and that is known as the backlash. Okay, you must know what is backlash and all, and what is its importance, or what happens if the backlash is there, or if there is more, or if it is totally nil and all. Okay, so how we can define backlash? So this one, second last. So the backlash, it can be defined as the difference between the thickness of a tooth and width of toothpaste of the mating gear along the pitch circle. Now, what is the thickness of the tooth? Thickness of tooth, it is considered, so this much is the thickness of the tooth along the pitch circle. Okay. Similarly, we have the next, this particular gap is basically nothing but the width of space, right? So up to this much it is clear. So now the difference between the thickness of the tooth and the width of tooth space of the mating gear along the pitch circle, it is actually known as the uh, backlash. Okay, so if you visualize like this figure is very okay. Let me redraw it something. Okay, okay. Suppose we have suppose the teeth from here. Okay, and suppose teeth here. Okay, and here and so on. Okay, so now if you visualize them, so you can see that whenever we are talking about this engagement of this gear, okay, so what basically happens, so we know that gear, how does it work? So they work by gradual engagement or meshing of the gear teeth, right? So gear A was gear A, okay, and gear B. Okay, so in that particular case, so teeth from gear A and gear B, okay, so they has to be properly meshed. Okay, and now suppose if this is the driver, okay, so by this particular meshing, only meshing of the teeth, that is actually they are in contact, that means somehow they are contacting. So actually from that, actually the torque is transferred to suppose the driven wheel B. Okay, so suppose this is the driver, okay, and suppose this is the driven. So in that particular case, how actually it is working? So see, actually if it is rotating like this, then our if I exaggerate this particular view, so basically what is going to happen? So if this is the teeth, Suppose this is the another teeth and all. Okay, and actually suppose the teeth from the other meeting gear suppose it is coming. Suppose here. Okay, if I exaggerate the view, and so in that particular case what basically is happening, so somehow whenever it is moving like this actually, okay, so this point uh, somewhere it will come in contact here, okay, it will suppose gradually if it is moving like this, okay, and it should come in contact here and ultimately the force through this particular point and all, okay, so the torque transfer will happen and thus it is going to the other gear is going to get the motion, right? So now what is this vectors, how we have defined them? So it's the difference between the thickness of the tooth and the width of tooth space of the mating gear at pitch circle. So now you can see that actually if I have already exaggerated, so basically there are certain difference between them, right? Yes, so if I consider the tooth thickness for this particular gear, so it's nothing but basically this portion, okay, along the particular circle, okay, and if I, in the case of this particular gear, if I consider this particular width, okay, width of space, so it also encompasses suppose from along the pitch circle only from here to here, and for the thickness it is here to here, okay. Now if you consider, that means whenever it is coming, when actually it is, you can consider as if it is filling up this particular width space tooth width, right, from this particular gear, suppose this tooth is filling up that particular vacant space. So in that particular case, if you along the pitch circle, you can say that you can get a difference between them, right? So if you consider both the values and if you subtract, then basically this clearance kind of thing, which we will be not using the word clearance, so that you can get. So theoretically, that is it, the that difference is known as the backlash. And now why we are saying that it's very important, the concept is very important. Up to this much, I think you have understood, right? Yes. Hello.
Yes, sir.
This is okay. Okay. Thank you. So now why it is important or what will happen to it if actually how it is working, so that thing we are going to discuss. So now what will happen in normal expectation, actually whenever our intention is what, whenever suppose if this is the driver and this is the driven, so in that particular case our intention is whenever the driver is rotating, so actually there should not be any motion loss and all, okay, so the motion transfer should happen to be to the driven, okay, without any loss and all. So in that particular case, see, if we already know that practically there will be some this particular backlash or this particular gap, so as to easily fill up that particular suppose to facilitate this engagement of both the gears and all, okay, that is there. And but if we have excess backlash, what will happen? So what will happen, you see, if suppose this gap is more, so basically what will happen, so sometimes what may happen, suppose if this is the condition, suppose as if this person is in this particular person and backlash was there and this much backlash was there, so totally this much gap you can consider as if it is gap, so this kind of gap is there. So now whenever it is rotating with a certain rpm, so this twitch it is coming, this is also coming in this particular direction, and after that suppose it is going to take this particular shape, take this particular position, okay, and thus suppose it is coming in contact and it will provide the torque to it, okay, all the force transfer etc will happen. So within that particular time what will happen, so whatever be the rpm of this particular wheel, so definitely it is going to take some amount of time so as to move from here to here and come in contact with this particular teeth. So now during that time what will happen, do you think that the whenever gear A is moving from here to here, there was no contact and only it is making the contact now, so within that time definitely there is no motion transfer etc that is happening to this particular gear, what was in but it was actually intended. So now what is happening, due to the excessive backlash if it is there, so some motion loss will be there and the precision of the motion will be lost. That means even if I have rotated it by some amount, which amounting to this much suppose, so within that particular time there is no motion we are getting in this particular will be, okay. So that means some, if backlash is more, so some motion is lost. So that is one problem. Apart from that, if the backlash is more, there may be what may happen, so some hammering kind of action it may happen on the tooth. So what will happen, so suppose this gap is there, right, so and now it is rotating. So in that particular time, with a particular speed, it is coming, and it is coming. It is hammering in this particular tooth. So if this kind of, if the backlash is more, so that kind of hammering kind of action also may happen, and because of that, some excessive noise also it will be there. Apart from that, so sometimes the tooth from this mating gear it gets weakened, and we know that the actually tooth of this particular gear, if the tooth fails, so the whole gear will fail. Okay, so even if one tooth breaks or it bends, so that is not intended. We want that whatever is the proper profile of the teeth, it should retain, and all the strength of the teeth it should be retained. There should not be any chipping and all. Okay, there should not be in like in normal, or you can say in ideal condition, there should not be any even wear and tear also, but wear and tear, gradual wear and tear, etc., it will be there. So those are the things. So that is about the different problems of backlash. But if for practical case, so to provide suppose some easy engagement and all, so somewhat and backlash is required also. Okay, but in a very minimal direction. Apart from that, to use lubricant, to use all those lubrication, etc., to make the film of lubricant on the surface of the mating gears, so as to reduce all the wear and tear, etc. We already know we use the lubricants in all the mechanical parts, all the moving parts and all. So similarly, in gear also we can lubricate them. And this backlash, a very minimal amount of backlash, it allows for retaining of the whatever is the lubricant and all. Okay, as well as filling up this particular thing. So if someone now asks you backlash, what is this, you will be able to answer, and whether it is required or not. Okay, what are the effect of backlash, that also I believe you will be able to answer. So about requirement of backlash, actually excessive requirement, it is in general backlash is a kind of loss only. Okay, motion will not be given to that, some motion will be lost due to backlash, but that is kind of very minimal amount of backlash is required also for this particular whatever I have already discussed. Okay, so that consideration. So those are the different nomenclature. Understood? So this nomenclature is important. You must know those things. We'll be in the next classes. We'll be using these words. I hope all of you have understood. I hope all of you have understood. Okay, so similarly, we have another word named velocity ratio of the gear drive. So it's nothing but a simple ratio. It's defined as the ratio of the angular velocity of the driven or the follower to the angular velocity of the driver. So velocity ratio VER. Okay, velocity. So it is angular velocity of follower divided by angular velocity of driver. Okay. So in terms of, it can be written in terms of your n also, that is RPM, in terms of angular velocity, radian per minute also, radian per second also, it can be written. So velocity ratio, what we can do here, omega 2 by omega 1. So omega 2 suffix 2 for driven or the follower, and suffix 1 it is for the driver. So which is equal to n2 by n1. And we already know they are from our previous knowledge how they are interlinked. So with respect to the size itself, okay, we already know it is it is d1 by d2. These things already we have discussed. Okay, the size effect. So n2 by n1 equal to d1 by d2. It is reverse. Similarly, it is equal to, itself is equal to t1 by t2. So this must you should remember. That means how they are, the teeth, where t is the number of teeth that is there. Okay, so how they are related. So because we already know omega equal to 2 pi n, so we can write for both the cases. Okay, so pi d1 n1 equal to pi d2 n2. Okay, so already we know pitch equal to pi d by t. So for both the cases we can write like pi d by d1 by t. Okay, because both the pitch equal to equal. So ultimately velocity ratio and the size as well as the number of teeth, how they are related, they are inversely proportional. Okay, so this you should know. So the law of gearing in the next class we'll be discussing, and with this particular very simple relationship, we can see one particular sort of problem. So what is given is very easy only. So two spar gears, it have got a velocity ratio of 1 by 3, 1. Okay, the driven gear has 72 number of teeth of 8 millimeter module, and it is rotating at 300 rpm. So you have to calculate the number of teeth and the speed of the driver. Also the pitch line velocity you have to find out. So what is given, driven gears has 72 number of teeth, so T2 it is 72, velocity ratio is given as one third, VR equal to one third, okay, 1 by 3. And this driven wheel is rotating at 300. So suffix is 2 and 2, 300 RPM. And module of the gear, it is 8 mm. So M equal to 8 mm. Okay, module will be same for both the machine gears. So what we know from this right now, okay, velocity ratio is given by N2 by N1, which itself is equal to T1 by T2, and it is given as 1 by 3. So I can write N2 by N1 also equal to 1 by 3, also T1 by T2 equal to 1 by 3. Okay, and all those values are already given. One of the values it is already given. Okay, so N2 equal to already it is given as 300 RPM. So N1 equal to 3 into N2. So it is going to rotate at 900 RPM. Okay, so similarly that itself is equal to like T1 by T2 also will be equated to 1 by 3. So I can write T1 equal to one third of T2. Okay, and T2 is already given number of teeth. The driven gear it has 72 number of teeth. So that given value I have just used, and we have obtained the T1 equal to 24. So the size you can indicate. Okay, so T1 that is the driver. Okay, that is smaller. 24 number of teeth is there. In the driven 72 number of teeth is there. Okay, and it is previously the driver was rotating at 900 rpm, and because we are using a gear of bigger size having bigger number of all those teeth, so we are reducing it by one third. Velocity ratio is kind of 1 by 3. Okay, that is velocity of driven to the velocity of driver. Okay, we have got a reducing type of engagement. Okay, so that means this way, by using proper gear or proper number of teeth or size, okay, you can either increase or decrease the velocity. So in this particular drive, what has happened? So velocity has got, it is kind of reducing drive. Okay, because driver is rotating at your 900 rpm, driven is rotating at 300 rpm. So you have reduced it, step down. It is, we are stepping down. Similarly, already we have to find out the pitch line velocity. So v suffix p, we already know pitch line velocity for both the machine gears. It is always same. Okay, so we can write in terms of maybe v equal to r omega. So we can use for gear 1 r1 omega 1, or if you use gear 2 r2 omega 2. Okay, so similarly omega is already we know 2 pi n by 60. If you don't use 60 divided by 60, it will be in minute, and if you divide it by 60, so it will be in second. So that is up to you. Similarly, r1 means, r means radius. Radius means the half of the diameter, d1 by 2, and 2 pi n remains like this. And we already know about module, how m equal to d by t module. Yes, so from there we can write d equal to, see, we know m equal to d by t, module equal to the pitch diameter by number of teeth. So d can be written as t by mt. Okay, m into t is d. So the one is m t1. So we have just put the values and we have obtained the result. So if you use in terms of suffix 2, that is the for the driven, there also you are going to get the same answer. And pitch line velocity will be, it is the linear velocity we are talking about. So it is meter per second. It is not angular velocity. Okay, pitch line velocity is not the angular velocity. So with this we have completed today's class. Let me know whether you have understood this problem or not. It is just by using the known expression.
Understood, sir.
Okay, so other thing also you have understood, right? The nomenclature and all.
Yes, sir.
Okay, so all of you have understood, I hope. Okay, it's an easy thing only. You go through the nomenclature once again. So if you don't have any doubt, we'll stop the class here. So thank you everyone.